Hello CM450, my name is David Hartman, and I'm going to help you through calculating square foot of contact area for wall forms in the AIC study guide, section 5G, number 3, on page 339. So here's a little background on the wall form system. The estimator must identify all of the individual components which make up the system to place concrete. Generally ply form with studs, wales, braces, chamfer strip, wall ties, tie clamps, nails, foam oil, bulkheads, and blockouts. The height of the concrete wall is the distance in decimals of a foot from the top of the footing to the bottom of the elevated slab finished floor. This is a very important height because it is utilized to calculate the wall forms, the reinforcement, and the concrete. Wall form system continued. Wall forms are placed along the outside and the inside of the wall and the full height of the wall. They are calculated in square foot of contact area. The formwork systems for concrete are the most important piece for concrete construction when it comes to cost. The erection and stripping of formwork, on average, makes up 60% of the total cost of concrete construction. So here's the problem we have, and this is our given information. As you can see, we have kind of an L-shaped building, 16 feet by 45 feet long, 32 feet, 22.5 feet, another 16-foot wall here, and another 22.5 side wall here. And you can see they give us a section 2 over S2, which is this section here. The important pieces we need in this are the width of the wall, which is 1 foot 2 or 1.67. Top of wall, which is the elevation, very important. We need 207 feet foot 4. They don't give us the bottom of the wall, but they give us the bottom of footing, which is 190 foot 6. But we have the depth of the footing, which is 1 foot 2, which gives us a height here at the bottom of the wall of 191 foot 8, which is 191.67. So we take that 207 minus our 191.67, which gives us a height of the wall of 15.67. So how many total square foot of contact area for the wall forms? The wall forms are always made up of two sides of formwork, as opposed to slab forms, which are only one side. Taking off the outside forms is quite simple, since they're wall forms. The dimensions given will always be the building dimensions. So what we do is just add up the perimeter of the building and then multiply by the height of the wall. Taking out the inside formwork is a bit different. It'll be different for every building you encounter. But according to this drawing, there are 4 inside corners and 2 outside corners. What this means is that you must subtract the width of the wall twice from the 4 corners as shown on the next slide. The width of the wall is 1.17. So what we have here are the 4 inside corners that we must subtract the width of the wall twice. And what I mean by that is, here we can see that here's the overall length of the wall, here's the width of the wall, 1.17, here's the width of the wall, 1.17. Here's our piece of formwork outlined in the red. So we need to subtract 1.17 twice. Same with this wall. As you can see, 1.17 here, 1.17 here. We need to subtract it twice from this piece of formwork, and so on and so forth. Now the outside corners, what they mean by that is that this piece of formwork here, what you can literally do is slide it up and have it match with the edge of this form, and it will be the exact length of this wall, which in this case is 22.5, and in this case over here we can slide this and it will be the exact length of this piece of formwork, which is 16 feet. So these two we don't need to do anything with. These four, we need to subtract the width of the wall twice. So here's what the book has us, or shows us, for taking off the formwork. As you can see, the outside forms, very simple. We just have our total perimeter, 45 plus 16 plus 2250 plus 16 plus 2250 plus 32 is 154 total lineal feet, times the height of our wall, 15.67, which gives us total square feet of 2,411.64. Now our inside wall forms is a bit different. Now recall back to this side, our 45-foot wall, our 16-foot wall, our 22.5-foot wall, and our 32-foot wall all need to be subtracted. The width of the wall needs to be subtracted twice. I'll go back to this slide and show again. Here's our 16-foot wall, our 45-foot wall, our 32-foot wall, and our 22.5-foot wall. So we will go through is subtract each extends 1.17 feet minus another 1.17 feet gives us 42.66, and so on and so forth down the line. 16 minus 1.17 minus 1.17, 13.66. These two walls, nothing needs to be done because they're outside walls, outside corners, and so on for our next other two walls. 2250 minus 1.17 minus 1.17 is 20.16. 32 minus 1.17 minus 1.17 is 29.66. So we take these, this total, or this number, add them up, which equals 144.64 times our 1566, which gives us 2,265.06 square feet. We add the two together, which gives us 4,676 feet, or 0.7 square feet. Here's a little visual that I put together so that you can see it better. As you can see, our total lineal feet for our outside 154 times our height is 2,411 square feet, and our inside corners 45, 16, 22.5, 32. They must have 2.34, which is our 2 times the wall width, subtracted from them. That gives us our total lineal feet of 144.64 times 1567, which is our height. This gives us our total square feet. And as you can see, the total square feet is smaller than the outside wall forms, which would make sense. And then we add those two together to give us our total square feet. I hope that helps, and good luck on the test.